Okay, I think I'm live now. Hopefully everyone is able to see the screen and the audio is perfect. If yes, just drop a yes in the live chat. Actually forgot to schedule the stream today. Even says yes. Okay, cool. Okay, all right. Okay, so can we have a count of how many questions you were able to solve today? Okay, and I'll be solving problem A, B, C, and D1. I am not so sure about D2 at the moment. We can try it in the stream. Steven says ABC, Suraj says ABD1. That's really nice. C was also kind of a tricky one. Like I also missed one edge case. Here D1, please. Yes, I'll be doing D1. I'm not so sure about D2. Maybe we can try D2 as well. Okay, all right. So I think we should start. Let's start with problem A only. Okay. All right. So in problem A, Marine is at a cosplay exhibition and is preparing for a group photo shoot. For the group picture, the cosplays form a horizontal line. Okay, this is not necessary. Currently, the line has n cosplays, which can be described by a binary string S. The ith cosplay is female if Si is equals to 0 and female if Si equals to 1. So if it's male, then it's 0, and if it's a female, then it's 1. Okay. To ensure that the line is beautiful, you can invite some additional cosplays, possibly 0, to join the line at any position. You cannot remove any cosplay from the line. Marine wants to know the minimum number of cosplays you need to invite so that the group picture of all the cosplays is beautiful. She can't do that on her own, so she's asking you to help. Can you help her? Basically, what they're actually trying to say is that okay, this line is important. A group picture is considered beautiful if for every contiguous segment of at least two cosplayers, the number of males does not exceed the number of females. So if this is one complete string, and if you take any subsegment from this, count of females should be greater than equal to males. Okay. So let's take the very first test case. The very first test case says 0, 0, and 0. Now, in this, since you're given that if for every contiguous subsegment of at least two cosplayers, that means just take all these subsegments of length 2. Okay, because if we have two subsegments, this is of length 2, and then another subsegment, this is of length 2. If both of these are beautiful, that means this complete segment of length 3 is also beautiful. If we have a segment of length 3, if these two are beautiful and these two are beautiful, that means this complete string is also beautiful. Okay, so you just need to check for every consecutive elements. Okay, now for this test case, in order to have these two elements, so this is male, this is male. If we insert one female between these, okay, these two are okay. Okay, these two are not okay. These two are also okay, but these two are not okay because after this we have another 0. Okay, so you need two ones here, 0, 1, 1, 0. Okay, also in this one, this is also not okay. If you take this substring, then there is only one female. Okay, basically, okay, let me write the other test cases also. Okay, so we had 0, 0, 0. In this, the answer was 0, 1, 1, 0, 1, 1, 0. The reason for this is because if we inserted only a single one, then this is beautiful, but this complete string is not beautiful. Okay. Similarly, therefore, we need to add two ones. Similarly, for these two zeros as well, we need to add two zeros. Okay. What if the string was 0, 1, 0 already? Then we just had to insert one more string, one more one. Okay. So that is the complete idea actually. If you have two consecutive zeros, then add two ones. If you have 0, 1, 0, then add 1, 1. Okay. So, and that's it. Okay. So basically, I just quickly show my code. Okay. Pretty easy problem. Okay, so what you had to do was when you're scanning the string, okay, if your current S of I is equals to 0, The way you could have implemented is that if you are at the string, okay, if this is your string, okay, and if you are at this particular index, and if this is equals to 0, then you check if the previous element, okay, was equals to 0. Okay, if it was equals to 0, then you had to add two ones. If this was equals to 1 and the previous element before this was equals to 0, then you had to add only single one. Only single one. Yeah, okay. So if it was 0 0, add 2. If it was 0 1 0, add 1. That's it. That is all you had to do in the problem. Okay. So I hope everybody is clear with the very first problem now. And I think we can move on to the second problem. Okay. In the second problem, okay, you guys were not able to see the board. I think that's okay. Or I'll just quickly explain again. Okay, the way I wrote the code. So basically, what I tried to say was that if this is your complete string and there is a certain 0 at this index, you check if the previous element was a 0. If it was 0, then add two twos. If it was 0 1 0, then add a single one. So basically, if it was 0 0, add two ones. If it was 0 1 0, add a single one. That's it. Okay, and that is exactly what I'm doing. So basically, if s of I is equals to 0, that means if my current index is equals to 0, then if s of I minus 2 is equals to 0 and s of I minus 1 is equals to 0, basically this is 0 1 0 condition. If that is the case, then count plus plus. Otherwise, if s of I minus 1 is equals to 0, that means it's a 0 0 condition. That means you need to add two ones. So it's count plus plus and like basically two times count plus plus. Okay. How do you solve D1? I'll come on to D1 as well. We are going in the order. So I'm done with A. Now we'll go to B, then C, and then D1. All right. Let's move to problem B. So in problem B, Marian wants you to count the number of permutations that are beautiful. A beautiful permutation of length n is a permutation that has the following property. So what the property says is that GCD of, okay, GCD of 1 times P1, comma 2 times P2, comma 3 times P3 till n times P4. GCD of this should be greater than 1. Okay. So if I take an example, let's take a permutation. Okay, this is just the definition of permutation. Okay. Let's take which case? For n equals to 4. For n equals to 2. Let's take n equals to 2 first. If our n is equals to 2, there are only two permutations, 1 2 and 2 1. If this is the permutation, then this string becomes GCD of 1 times 1, comma 2 times 2, which is actually GCD of 1 comma 4, which is 1. Okay, and in this case it becomes GCD of 2 times 1 and 1 times 2, which is actually GCD of 2 comma 2, which is 2. Therefore there is one permutation which is beautiful. Therefore the answer for this, for n equals to 2, is 1. Now let's take n equals to 4. Okay, if n is equals to 4, okay, then let's see how many permutations do we have. We have 1 2 3 4, we have 1 2 4 3, or instead of doing this, what we have to do is GCD of 1 times the very first value, 2 times the second value, 3 times the third value, and 4 times the fourth value. We want this GCD to be greater than 1. Okay. Now, since this has to be greater than 1, let's try for a GCD to make this GCD equals to 2, because 2 is the easiest GCD possible after 1. Okay. So, in order to have this GCD equal to 2, every value, okay, every value has to be even. So, this has to be even, this has to be even, and so on. Okay. Now, in order for every value has to be even, if we want an even value, it can only be obtained if we multiply either even time into even, or if we multiply even into odd. Okay, we cannot have odd into odd, because odd into odd will actually give you an odd number. Okay, so how to do. If you see, this one is odd, this 2 is even, this 3 is odd, and this 4 is even. And what all numbers do you have? You have 1, 2, 3, and 4. You need to arrange these 1, 2, 3, 4 in any order. Okay. Now, since this is an odd number, you need an even number here. Now, how many even numbers do you already have here? You can either use 2 or you can use 4. Therefore, you can either use 2 or you can use 4. Similarly, for this one, 2 is an even number. Okay. Now, since 2 is an even number, you need a odd number here. Okay. The reason we won't take any even number here is because we need even numbers for the further values. So, we'll try for an odd number. Okay. Now, how many odd numbers do we have? We have 1 and 3. So, we can either use 1 or 3 here. Coming on to this one, this is odd. Therefore, we need an even number. So, again, 2 or 4. And here, 1 or 3. Now, how many options did we have for this position? We had 2 options. Okay. So, we had 2 options. Okay. Similarly, for this position also, we had 2 options. Now, at this position, we do have 2 options, but one of these is already utilized at this index. Okay, therefore, we only have one option here. And similarly, for this one, we do have 2 options here, but one out of these 2 values is already used at this index. Therefore, one option only. And when you multiply all these things, you get 4. So, for n equals to 4, the answer is 4. Okay, let's try the same thing for n equals to 6. Okay. Now, if you try for n equals to 6, okay. Okay, this is 1, 2, 3, 4, 5, 6, 7. This position will be multiplied by 1, this will be multiplied by 2, this will be multiplied by 3, then 4, 5, and so on. Now, since this is odd, you need an even number here. Since this is even, you need an odd number here. This is odd, therefore you need an even number here, and so on. Okay. Now, since this is odd, and you only have 1, 2, 3, 4, 5, 6. Out of these, 1, 3, and 5 are odd, 2, 4, and 6 are even. You have 3 even numbers for this position. Coming on to 2, you need an odd number here. Okay. And you have 3 odd numbers possible. Coming on to this 3, you need an even number here. In total, you had 3 even numbers, but you have already used 1 even number at this position. So you have 2 more even numbers here. Okay. Coming on to this one, 4 is an even number. So you need an odd number here. And you have 3 odd numbers in total, but one of them is utilized here. Since one of them is utilized here, you have 2 more options here. Then 5, oh, this 7 is not. This 5 is an odd number, therefore an even number is required here. In total, we had 3 even numbers. 2 out of these 3 even numbers were used here and here, therefore we only have one option left. Similarly, for this one, this is an even number and you need an odd number here. And there are 3 total odd numbers. Out of these, 2 are already used, so one option. So this is to be multiplied. This actually gives 3 times 3 is 9, 2 into 2 is 4, 9 times 4 is 36. So for n equals to 6, the answer is 36, which is nothing but 3 factorial into 3 factorial. And hence we can say for n equals to 8 also, it will be similar only, 4 factorial into 4 factorial. But what about an odd number? Now let's see for an odd number. Let's say we had n equals to 3. Okay. If we had n is equals to 3, in total you had 2 odd numbers and 1 even number. Okay, so when you try to place these numbers at 1, 2, and 3 position, you know that 1 is an odd number. Therefore, you need an even number here, and in total you had 1 even number, so you place this here. 2 is an even number, okay, and you need an odd number here to multiply by 2, and you have 2 options for odd numbers, so you write 2 here. Okay. Now, 3 is an odd number. Okay. Therefore, you need an even number here. You had 1 total even numbers and that even number was already used here. Therefore, you don't have any number for this position. and therefore the answer for this one is actually going to be -1, because there is no way you can ever get a beautiful permutation. So basically for every odd number your answer is -1, and for an even number your answer is actually like n by 2 factorial into n by 2 factorial. And I'll quickly show my code as well. So this is the code for n. If it's an even number, I'm just calculating the answer, otherwise it's 0. Okay, you have to print 0 instead of -1. Now, the answer is actually n by 2 factorial into n by 2 factorial. Okay, so what I'm actually doing is I'm running a loop from 2 till n by 2, multiplying my answer by I, finding the mod at every value. Okay, and then I just multiply the answer by answer, because it is n by 2 factorial into n by 2 factorial, and then I again find out the mod and then just print the answer. And I hope everybody is clear with problem B as well now, and we can move on to problem C. Okay, cool. Okay. I only see 12 likes in the stream. Can you please like the stream so that it reaches a wider audience? We have 36 people. Okay, cool. Shall we move on to problem C now? And do subscribe to the channel as well. Okay. Okay, cool. Let's move on to problem C now. Shinzu loves permutations very much. Today, she has wrote a permutation P from Juju to play with. Okay, the ith cycle shift of a permutation P is a transformation of the permutation such that P of 1 till n will now becomes P of n minus. Okay, so basically what they're trying to say is that if you had a permutation, let's say 1, 2, 3, 4, after one cyclic shift, this permutation will become 4, 1, 2, 3. After one more cyclic shift, this will become 3, 4, 1, 2. So basically the value at the end is actually coming into the starting. Okay, so again for this one it will be 2, 3, 4, and 1. Okay, so this is what a cyclic permutation means in this one. Okay, now let's define the power of a permutation P as the number of distinct elements in the prefix maximum arrays B of the permutation. The prefix maximum array B is the array of length n such that Bi is equals to max of Pi till E. So let's take an example. We have 2, 3, 1, 5, and 4. Okay, now max of this prefix is 2. Max of this prefix is 3. Max of this prefix is 3. Max of this prefix is 5. And max of this prefix is 5. This is what a power of permutation says. Okay. Now, what they actually want us to do is, unfortunately, Shuzu has lost the permutation P factorial. P, the only information she remembers is that an array C where Ci is the power of the I minus 1th cyclic shift of permutation P. Okay, she's also not confident that she remembers it correctly, so she wants to know if her memory is good enough. Okay, so let's do it for this case only. Okay, so let's take the very first test case, or let's take this only. Okay, is this for this one only? This is not for this one. Okay, let's take this array which is 5, 1, 2, 4, 6, 3. 5, 1, 2, 4, 6, 3. Okay, after one cyclic cycle, it will actually become 3, 5, 1, 2, 4, and 6. After another, it will actually become 6, 3, 5, 1, 2, 4, and so on. Okay, now if you try to find out the prefix of this one, it actually becomes 5. Okay, I'll actually write it with a different pen. So this is actually 5, 5, 5, 5, 6, and 6. And the total number of distinct values in this string in this array are now 5 and 6, so 2. Okay, in this one it is 3, 5, 5, 5, 5, and 6. So the distinct elements in this are 3, 5, and 6, so 3. For this one it is 6, 6, 6, 6, and 6, and the number of distinct elements are 1. Okay, so the C array which they are actually talking about is this one. So 2, the array is actually 2, 3, 1, and then the next permutation of this one, which will be something. Then you find out the prefix of this one. and then you find total number of distinct elements, and then you put this position here. Okay. Now you are given this value, okay, this complete array, and you need to find if this value is a legit value for any permutation, and you just need to print yes or no. Okay, so let's take the examples only, okay, because they pretty much have the complete answer. Okay, so let's look at a few things. Okay, let's say we had some permutation. Okay, we found out the prefix, and in that prefix we had, let's say, two distinct values. Okay, is there any way that after one cycle in the new permutation, if you find out the prefix and then if you find out the max value of that, the distinct elements in that become 4? Is that ever possible? Okay, what we would actually be doing is we'll just take this x from the very last value and we'll actually put this here. Okay, so whatever distinct values we had for this one, they will remain same. Okay, this value will either be smaller than the very first value. If it is smaller, then this 2 will become 3. If it is larger than the very first value, this will remain 2 only. Okay, or maybe something less than 2, but not 4. There is no way this will ever become 4, because we had some number of maxes here. Only one will be added because of this. Maximum one will be added because this x can be smaller than the very smallest value from this one, and therefore it will only add 1 into this. Okay, there is no way we can actually add 2 more values such that this becomes 4. Okay, so this is one condition, that after one cycle there is no way that the total number of distinct values becomes plus 2 than the previous one. Okay. भैया थोड़ा ऑडियो गेन इंक्रीज कर सकते हो? Yes, I can do that. Just give me a minute. Okay. I hope it's better now. I have added some gain. Okay. Okay, cool. Okay, so this is one condition, that uh, in the array a of I plus 1 minus a of I will be less than equal to 1. Okay, this value cannot be 2, like plus 2 than a of I. Okay, this is one condition. Okay, then the other cases, okay, let me just, the other case is that for the complete array, let's say this was for n equals to 4. If the n is equals to 4 and if the last value is 4, in the next cycle 4 will come at the very first index. Okay, and hence the prefix of this will be 4444, because this is the largest value, and hence the total number of distinct values in this one is going to be 1. Okay, and now if you see, when you again do a cycle for this one, okay, again do a cycle for this one, the whatever value you had in the last will come in the front, and this 4 will come here, and so on. So the total number of distinct values in this one will be 2, in this one it was 1. Then in the next case again, you will have 2 more values here, and then 4, and then some value here, and this is the complete permutation. And the total number of distinct values in this one will be either 2 or 3. Okay, and again in the next iteration, okay, you will have what, 3 values before 4. Okay, and this will either have what, the max as equal to 2 or 3 or 4. Like the total number of distinct values in the the max value of the permutation will be 2, 3 or 4. It won't ever, this one will never come again, because this one will only come when you had this 4 at the very first index, and since there are only n cycles, okay, you only have to do n cycles. Okay, this 4 will only reach at the very first index only once. So for the complete array, you'll only have this one time. Okay, now let's take the array only. Okay, let's take some inputs. Okay, so if the very first input is 1 only, so that is okay, and the next input is 1 2, Okay, this is also okay because this will come for a permutation of what? 2 1. Because if initially the permutation is 2 1, that means the max values are 2 and 2, and there's only one distinct values, therefore 1. And then after one cycle, this becomes 1 2. The max values also become 1 2 only, and total number of distinct values in this one are 2, therefore 2. So 1 2 is possible. Next value comes as 2 2. Is there any way we can actually make 2 2? No, there is no way we can actually make 2 2 because there is no one in this one. Okay, as we already established that there is at least one like at least one needs to be present one time in this one, and since there is no one, that means like since n is equals to 2 in this one, the permutations are 1 2 and 2 1. Okay, okay, and neither of these cases are present for this one, because if we have one here, okay, the max array would become 1 2 only, and the total number of distinct values will be 2. Okay, but for this one, when you have 2 at the very first index, the max array becomes 2 2, and there's only one distinct value, but this one is not present here. Okay, so this is not a valid answer. Then coming on to the next one, we have 1 2 4 6 3 and 5. Now this one is okay, this 2 is okay. Let's look at this 4. In a certain permutation, you had two distinct values in the max array. Okay, then suddenly after one cycle, this 2 becomes 4. And we already established that this is not possible, because we'll only pick up one value from the very end, bring it at the very first. Therefore, we can either have 1 or 3 or 2 or 3. These are the only three values possible for the distinct values. 4 is never possible, because in order to get 4, we'll at least have to add two smaller values in the very small starting. Okay, so 4 is not possible. Therefore, the answer for this one is actually no. Okay, let's come on to the next one, which is 2 3 1 2 3 4. Okay, so in this, if you see that we have one time, okay, and there are no two elements whose difference is greater than 1. Okay, therefore the answer for this one is yes. Okay, and if we even like, should we try to make a permutation also? Okay, let's try. So we have two values. Okay, so we need to have 6 values in the very starting. Okay, okay, I don't think like this is necessary. If you really want to see the permutation is 5 1 2 4 6 3. Initially the max array is 5 5 5 5 6 3. There is only like two distinct values. Sorry, this is 3. Two distinct values, so we have 2 here. After one cycle, it becomes 3 5 1 2 4 6. It was 3. The max array was 3 5 5 5 5 and 6. There are 3 distinct values, so 3 here and so on. Okay, now, so these are the two conditions that you just need to check, that one is present at least once, and there are no two consecutive values whose difference is greater than 2. Okay, now less than 1. Okay, okay. So let me show you a code. I actually got a wrong answer on this one, so I'll actually show you someone else's code. Okay, who should we open? Let's look at his code. I'm hoping his good one. Okay, yeah. Okay, let's look at this code. So basically what this person is actually doing is, let's look at which test case. Let's look at this test case. We had 2 3 1 2 3 4. Okay, what this person is doing is that he's first checking, do we have 1 in this string? Okay, so basically first he scanned the complete array, and then he checked in the complete vector, do we have 1 present? If we don't have any 1 present, then you just print no. But if we have 1 present, then rotate the array from this iterator. So basically the new array will become 1 2 3 4 3 2. Sorry. This had to become, so basically there 3, yeah, 1 2 3 4 3 2. Okay, and now if you check, there is no two consecutive values whose difference is greater than 2. Okay, a second. Yeah, okay. Okay, and that is all you had to do. Okay, I hope this is also clear to everyone now. And I think we can move on to problem D. Let's move on to problem D. Okay, so in problem D, what they're actually trying to say is that you have two numbers L and R. Okay, you have one L and one R. Okay, and you have a permutation from L and R. Since in D1 it is written that L is equals to 0, so we'll assume that L is equals to 0. Basically, what you have is a permutation from 0, 1, 2 till R. Okay, you have a permutation of all these numbers. Now, what you do is you actually find the XOR value with X of every index, of every like value at the index. And then the new array is generated and you're given this array. And you need to restore this array. Okay. And figure out what was this X. Okay, so this was the problem. And now how to do this? So if you see, let's say, okay, I'll actually write binary representation of a few numbers first. Okay, so 0 is actually 0, 0, 0. 1 is 0, 0, 1. 2 is 0, 1, 0. 3 is 0, 1, 1. 4 is 1, 0, 0. 5 is 1, 0, 1. 6 is 1, 1, 0. 7 is 1, 1, 1. And 8 is, okay, let's take 8 also. 8 is, okay, let's not take 8. Now, let's say R was equals to what? 3. If R was equals to 3, that means we need to take these 4 values. Okay. And let's take X also. Let's say this is the X and these are the indexes. Now let's look at the very first value. If this is equals to 0, okay, these indexes will remain the same. Okay. If this is equals to 1, these indexes will rotate. So basically this 0 will become 1, this 1 will become 0, this 0 will become 1, and this 1 will become 0. Okay. Now, similarly for this one also, these will rotate. So this 0, 0 will become 1, this 1, 1 will become 0 if this index is equals to 1. Okay. Now, how do you decide when you need to set the bit and when you do not need to set the bit? So, the way to do this is actually, if you find out, okay, let's take R was equals to 6. If R was equals to 6 or R was equals to 5. If R was equals to 5, how many ones did you have in the very first index? You had 3 ones. 1, 1 and 1. Okay. And how do I explain this? Okay, let's take the test case only. Let's say R is equals to 3 and the array you were given was 4, 7, 6 and 5. And in 4, 7, 6 and 5, you had 4, 7, 6 and 5. In 4, the binary representation of 4 is 1, 0, 0. 7 is 1, 1, 1. 6 is 1, 0, 1, 1, 0. And 5 is 1, 0, 1. Okay. If you see at the last index, you have 2 ones. Okay. And in these also you have 2 ones. Okay. If you set the bit, or if you, okay, so basically in this one, there is no, let's start with the very last one. Okay. That will be easier to understand. In this one, we have 0 unset bits, 0 set bits. But in this, we have all the 4 bits as set. If we take in X, the very last bit equal to 1, all these set bits will convert to 0, which is what we need. Similarly, in this one also, you have what? 2 ones. Okay. And in this also, you have 2 ones. Therefore, you can either keep this 0 or you can either keep this 1. There is no issue. Similarly, for the last one also, you can either keep the 0 or 1. Okay. So basically, if you had like 1, 0, 0, or you had 1, 1, 0, or you had 1, 0, 0, or you had 1, 1, 1, or you had what 101. All these values will give you like a permutation of 0, 1, 2, 3 only. Okay. And that is actually basically it. Okay. If you actually, I'll actually give you a better example. So let's say if r was equals to 6. If r was equals to 6 and you had to take the sum of these values, you have two ones here. Okay. If you have two ones here and in whatever array you were given at this index, if you had any set bits which were not 2, like the count of those set bits was not 2, then you actually need to set this bit so that all the set bits in that changes and they become equal to this one. Okay. Similarly for this one also, you have two set bits. If in your array the set bits at this index, the count of set bits at this index total count is not 2, then you just need to like in x set that bit so that every bit is reverted and they become equal to this one, and same for this one. And that is how you have to do d1. Now this works for d1 only, this doesn't work for d2. What is the reason behind, like why does this not work for d2? Okay, the reason it doesn't work for d2 is because in d1, okay, it is actually starting, everything is starting from 0. Okay, therefore all the values are equally distributed. Okay, but if L was actually starting from, let's say, this 2 after this, okay, we didn't have equal number of zeros and ones after this, therefore we cannot actually check the prefix. I don't really know like how many of you are able to understand like what I'm trying to say, but since it is not starting from 0 0, therefore you cannot say like how many ones and zeros do you really need. Okay, and therefore this doesn't work in d2. Okay, I'll also show you the code for this one quickly for d1 only. Okay, so this is the code. Basically what this is just a general function in which if I give it a number, okay, this is just a general function in which I just give a number and it returns me a vector of the binary representation of that number. Okay, so what I'm actually doing is I have a set count array, 2D array of size 2005 and 18 columns. Okay, so in this what I'm actually doing is for every I till 2005, I am finding the binary representation of that particular I and storing it at this set count of I. Okay, so basically my set count I will actually store the binary representation of I plus the binary representation of all the previous values. Okay, so basically in this temp I'll receive the binary representation of I, then I'll add that to my set count. So basically set count I will contain the binary representation of all the numbers from 0 to I, and any index of this set count I, so basically any column of this one will have a summation of how many set bits all the numbers had from 0 to I minus 1 for this particular index. That is what I have in set count. So basically like this, if for 5 this is what 3, that you have 3 ones before this, for this one you have 2 ones before this, and for this one you have 2. So set count 5 will actually be 2 2 3. Okay, and then what I do is I come into this while loop. For every test case I scan LNR, I already know that L is equals to 0. I again make the same set count with the name set count 1, and again do the same thing. Okay, so I find out the binary representation of array I, then I like populate my set count I. Okay, so basically this set count I is nothing but accumulation of all the binary representations of all the previous numbers for that particular index. Okay, and then I just check that if like till r my any index is not equal to the other array, then I just set this value for the answer, otherwise I don't set it, and that's it. Okay, that's it for problem D. And with this I think like I can end the stream. D was a little like I don't really know like how many people were able to understand the solution of D. Okay, cool. And with this I think I can end the stream. You can just go to my like account and look for all my submissions if you want.